All right, this is the next lesson in geometry. It's called rectangles, rhombi, and squares. Okay. So the unit overall is called quadrilaterals, which is a four-sided polygon. And we already talked about parallelograms, which is a special kind of quadrilateral. Now we're going to talk about special kinds of parallelograms. And there's three of them. There's rectangles, there's rhombi, which is the plural of rhombus, or it might be called rhombuses. Either one is fine. And then there's squares. Okay, so these are all special parallelograms. So it means that everything that's true about parallelograms is also true about rectangles, rhombi, and squares. Okay, so we're going to start with rectangles today. A rectangle is a quadrilateral with four right angles. A rectangle is a quadrilateral with four right angles. Since both pairs of opposite angles are congruent, it follows that it is a special type of parallelogram. Thus, a rectangle has all the properties of a parallelogram. Okay? Because the right angles make a rectangle a rigid figure, the diagonals are also congruent. Okay, so that's new. Okay, the diagonals are congruent. Okay, so that's the first theorem for today. If a parallelogram is a rectangle, then the diagonals are congruent. Okay, that was not true about parallelograms in general, but it is true about rectangles. Okay, so if this is your rectangle right here, and then you have your two diagonals drawn in, you know that AC is congruent to BD. Okay, the diagonals are congruent in a rectangle. So here we go. This is just a summary, basically. If a quadrilateral is a rectangle, then the following properties are true. The opposite sides are congruent and parallel. The opposite angles are congruent. The consecutive angles are supplementary. Now, those first three things are true for any parallelogram. But this is not true for any parallelogram. We just talked about this. For a rectangle, the diagonals are congruent and they bisect each other. And all four angles are right angles. Okay. This next theorem, this is basically the converse of the theorem I just showed you. If you know the diagonals of a parallelogram are congruent, then you know that the parallelogram has to be a rectangle. Okay? So if you know the parallelograms, if you know a parallelogram has congruent diagonals, then it means that it is a rectangle. Okay, so example one, quadrilateral MNOP is a rectangle if MO equals 6x plus 14 and PN equals NX plus 5, find the value of X. And I'm going to take it one step further. I'm also going to find each diagonal. Okay, so first let's find X. Since it's a rectangle, it means the diagonals are congruent. So it means that MO is congruent to PN. So it means that they're equal. I'm not going to label the diagram because that might make it a little messy, but 6x plus 14 equals 9x plus 5. I'll subtract 9x on each side. Now subtract 14 on each side to get negative 9. So therefore x equals 3. But let's just double check the answer to make sure we did it right. Let's get each diagonal. Okay, so MO equals 6x plus 14. So 6 times 3 plus 14. 18 plus 14 is 32. Now let's also get PN. PN is 9x plus 5. So 9 times 3 plus 5, because x is 3. 9 times 3 is 27, plus 5 is 32. So you can see it works because the diagonals are the same, 32 and 32. That's a way to check over your work. But on a quiz, I might just ask you for the diagonals as well, if I were to give you that problem. I'll circle each of these just because in the future I may just ask you for those. Okay. Quadrilateral ABCD is a rectangle. Find X and Y. All right, let's start by getting X. Okay. Since it's a rectangle, you know that you have 4 right angles. So angle A is a right angle. So it means that it's 90 degrees. So it means that 9x plus 20 plus 4x plus 5 equals 90. Solve that for x. 13x plus 25 when you combine like terms equals 90. Subtract 25 on each side. 13x equals 65. X equals 5. All right. Now, the 2 angles that are labeled with the y's, those are going to be congruent because those are alternate interior angles, and alternate interior angles are congruent. So, y squared minus 1 has to equal 4y plus 4. What I would suggest you do is I would suggest you solve this by getting it equal to 0. So I will subtract 4y on each side. And I will subtract 4 on each side to get negative 5. Okay, so I just got it equal to 0. And now what I'm going to do is I'm going to factor. I am going to find 2 numbers, then multiply to negative 5 and add to negative 4. Find 2 numbers, I multiply to negative 5 and add to negative 4. It's going to be y minus 5 and y plus 1. Because negative 5 times 1 is negative 5, and negative 5 plus 1 is negative 4. Now you're multiplying 2 terms to get 0. The only way that's possible is if one of them is 0. So either y minus 5 equals 0 or y plus 1 equals 0. That would give you y equals 5. And that would give you y equals negative 1. But you have to double check to make sure they work. Okay? These values could technically be negative, but the angles cannot be negative. So let's test y equals 5 and see if that works. Okay? Let's test y equals 5. Y squared minus 1. 5 squared minus 1 is 24 degrees. 25 minus 1 is 24. Let's check this one. 4 times y plus 4. 4 times 5 is 20. Plus 4 is 24. So that works. They're both 24. So y equals 5 works. Okay, I'll circle that. Or box that in. And now let's test the other answer. When y is negative 1, 4 times negative 1 is negative 4. Plus 4 equals 0. You cannot have an angle at 0 degrees in this problem. Okay, that angle is not 0 degrees. It's not possible. So it means y equals negative 1 is called an extraneous solution. Okay, so just disregard that. Okay, I'm just going to write down disregard. That way you know. Okay, don't circle that. That's not an answer. Okay, y equals 5 is the answer. You can write disregard, or you can just like cross it out or just X it out. Just know that's not an answer, okay? Y equals 5 is the one that works. So those are rectangles. Now we're going to move on to rhombi or rhombuses, okay? So this next definition, a rhombus is a quadrilateral with all four sides congruent, a rhombus. Since the opposite sides are congruent, the rhombus is a parallelogram. Okay. So again, like I said in the beginning of the lesson, we're doing three shapes today: rectangles, rhombi, and squares. And remember, these are all parallelograms. So all the properties that we learned about parallelograms applies to all three of these. But they have extra properties because they're special parallelograms. Okay. So there are three other characteristics of rhombi, which is the plural rhombus, or you may see it called rhombuses. So there's three extra characteristics of rhombi. Okay. The first one, the diagonals of a rhombi, the diagonals of a rhombus are perpendicular. Okay, so you have this diagonal BD and this diagonal AC. They're perpendicular, so they form four right angles in the middle. Only one's labeled here, but these are all right angles. You can get that using like vertical angle theorem and linear pairs. These are all right angles, all four angles in the middle. So the diagonals of a rhombus are perpendicular. Okay, and the converse is true. If you know, suppose you know the diagonals of a parallelogram are perpendicular, then you know it has to be a rhombus. Okay? And there's one more theorem. Each diagonal bisects a pair of opposite angles. Okay? So in a rhombus, you have the two diagonals, and they bisect the opposite angle. So if you look at this angle right here, okay, you see how okay, so you see how this has one arc and this has one arc? This has one arc and this has one arc. So this diagonal bisects angle B and angle D. So angle B is cut into two congruent angles, and angle D is cut into two congruent angles. And the same thing for the other diagonal. This diagonal bisects angle A and angle C. So angle A, you can see, is cut into two congruent angles. Angle C is cut into two congruent angles. Okay? Let's move on. Let's try example 3. You have a rhombus. Rhombus QRST. Find y if the measure of angle 3 equals y squared minus 20. Okay? I drew that in myself ahead of time by mistake. Hold on. Okay? So since it's a rhombus, you have four right angles in the middle because that's one of the theorems I just gave you. Okay? So label the right angles. We have four right angles in the middle because the diagonals are perpendicular. So that means that the measure of angle 3 equals 90 degrees. Okay? The measure of angle 3 equals 90 degrees. Let me see. Measure of angle 3 equals 90 degrees. I'll put it like this. So it means that y squared minus 21 equals 90. Solve that for y like you would in algebra. Add 21 to each side. Actually, you know what? I have a typo. Let me just fix that really quick. I want that to be 31. Hold on one second. All right. Sorry about that. All I did was I had a typo. So all I did was I changed that 21 to a 31. I want that to be 31. Okay. So 31, 31. So I'm going to add 31 to each side. I'm going to get y squared equals 121. Now, you got to think back about how to solve that. Okay. So what we're going to do is we're going to take the square root of each side. Okay. So when you take the square root of each side, the square root of y squared is just y. You're going to take the square root of 121, but when you're solving equations, you take the positive and negative square root. So that means y is going to equal positive and negative 11. Now, y can be negative. Y can be negative, that's fine. So let's check and see if that works. When y is positive 11, we have 11 squared is 121, minus 31 equals 90, that works. When y is negative 11, we have negative 11 squared is positive 121, because negative 11 times negative 11 is positive 121. And minus 31 equals 90. So both of these answers work. So I'm going to circle a box, put them both in. You can say y equals positive and negative 11 like that. Or you can say y equals 11, circle that. Y equals negative 11, circle that. Okay. Find the measure of angle TQS if the measure of angle RST equals 56. Okay. So here's what you need to know. Since RST equals 56, that angle is bisected. Okay? Because a diagonal in a rhombus bisects a pair of opposite angles. So this angle is bisected. So I put one arc in here, one arc in here. And the same two arcs are going to go in here. So one arc there, one arc there. Because the opposite angles in the parallelogram are always congruent. And since it's a rhombus, each angle is bisected. So this angle, this angle, this angle, and this angle, those are all the same. Okay? So what you're going to do is 56 divided by 2 equals 28. And that 28, 56 divided by 2 is 28. That 28 applies to all four angles. So 28 is right there. 28 is right there. 28 is right there. And 28 is right there. So the final answer for that problem would be the measure of angle TQS equals 28 degrees. Okay. So we talked about rectangles and we talked about rhombi. If you have all the characteristics of a rectangle and a rhombi all combined into one, that is a square. Okay? So if a quadrilateral is both a rhombus and a rectangle, then it is a square. Okay? In other words, if you have four right angles and you have all four sides congruent, then it's a square. So all the properties of parallelograms, rectangles, and rhombi can be applied to squares. Okay, so let's look at this. In general, we started with quadrilaterals, which are any four-sided figure. A parallelogram is a special quadrilateral. A rhombus, or rhombi if you're talking plural, and a rectangle, those are special parallelograms. And a square is also a special parallelogram. A square is when you combine rhombi and rectangles. Okay? So this last example right here. It might be a little hard to see on the video. The infield of a baseball diamond is a square, as shown below. Okay, so we have a square. This is a square. The question is the pitcher's mound located in the center of the infield? Okay. So this might be a little hard to see, but I think everybody knows that follows baseball that this is 90 feet right here. 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 Okay, most people that follow baseball know that. And if you follow baseball, you might know the answer to the question ahead of time. But is it a square? So basically, if it's in the center of the infield, then this part right here, 60 feet, 6 inches, should be the same as this part right here, right? Let me do that. Let me see if I can add some color to help us out. So that red segment, that red diagonal, should be the same as this blue diagonal I'm going to draw. Since we have a square, the two diagonals should be congruent because that's true for rectangles, and everything that's true for a rectangle is true for a square. So those two diagonals should be congruent if it's in the center. So what you're trying to see is 2 times 60 feet, 6 inches. Equal to the other diagonal, which I kind of drew through, but that says 127 feet. And then 3 3/8 inches. That's basically what you're checking, okay? If those are equal, then yes, the pitcher's mound is in the center of the infield. If they're not equal, then no, the pitcher's mound is not in the center of the infield. That's essentially what you're doing to answer the question. So when I do 2 times 60 feet, 6 inches, okay, I mean, you can distribute if you want, so I'll distribute. Why not? That gives me 120 feet, 12 inches. So I'll say is 120 feet, 12 inches equal to 127 feet, 3 3/8 inches. Well, I'll just simplify this right now. That's 121 feet. 120 feet plus 12 inches, that's 121 feet. So is 121 feet equal to 127 feet, 3 3/8 inches? No. They're not equal, okay? The diagonals should be equal, okay? They are actually equals, okay? So the red diagonal is equal to the blue diagonal. But when I double this, that's not equal to the blue diagonal, so it means that the pitcher's mound is not in the center of the infield, okay? I'm going to say no. You probably know that already if you follow baseball, that the pitcher's mound is not actually in the center of the infield. So no, the pitcher's mound is not in the center of the infield. Okay, and again, just to recap that, okay, if it was in the center, then this part down here, 60 feet, 6 inches, would be the same as this part right here, 60 feet, 6 inches. Okay, so that total red diagonal that I drew became 121 feet, which is not the same as the blue diagonal, okay? Because the red and the blue diagonals are the same. They are the same, but when I double this, it's not the same as the blue one. Therefore, the pitcher's mound is not in the center of the infield. Okay, I'm not gonna write any more. I mean, my explanation is my work above. Okay, I guess I can write that in words. I'll say the two diagonals are congruent. The diagonals also bisect each other. Then I'll say my work above shows why the pitcher's mound is not halfway in between. Okay. So again, just to recap that, I'm not going to write anymore because I basically explained why above in my math work. But remember, the diagonals are congruent. So the red diagonal does equal the blue diagonal. But since when I double 60 feet, 6 inches, I don't get the blue diagonal's length, it means that the pitcher's mound is not in the center of the infield. And this is my work showing that. Okay. So remember, we started with quadrilaterals, which is any four-sided polygon. Then we moved on to parallelograms, which is a special quadrilateral. And today we did 3 special parallelograms: rectangles, rhombi, and squares.